Welcome to chapter 11. We're going to be talking about polygons and circles and area. So the basic underlining ideas are ones that you've been talking about for a while. What's going to get fun is when we start like bringing in some of the other skills we've learned this year. For example, we'll be bringing in triangle relationships. We'll be bringing in trig functions. We will be applying those skills as we go along. So the underlying aspects of what we're talking about, you've heard. It's just we're bringing in more to just, keep you on your toes a bit, shall we say. So we're going to start with 1111, talking about parallels and triangles to begin with. Just some vocabulary to help you out with this. The base of the parallelogram can be any side of the parallelogram, and the height is the perpendicular distance. That's the cue here, the perpendicular distance between the two bases. The base of the triangle can be any side of the triangle. The important is the height is the length of the altitude from the base. And keeping in mind that this is also perpendicular, okay? So it gives us a little bit of flexibility as we're trying to figure out the height and so on. A couple of things, the area addition postulate. We've talked about segment addition postulate. We've talked about angle addition postulate. Now we're talking area addition postulate. Basically means that it's the sum of all the areas that make up the figure, okay? And then the area congruence postulate says if two figures are congruent, they have the same area, because congruent means same shape and same size. All right, so the area of a parallelogram is the base times the height. Not much has changed since you started learning that in 6th grade. So the height is always perpendicular to the base. And in this case, we could have had this be the base and then the perpendicular height, and we would have gotten the same thing. All right, so again, it doesn't matter which one is the base. All right, so let's find the perimeter and the area of the parallelogram. So with perimeter, we know that you add up all the sides. So in a parallelogram, your opposite sides are congruent. So then the perimeter is equal to 2 times 20 plus 2 times 32. So the perimeter is equal to 40 plus 64. So the perimeter is equal to 104. Okay. Now the area is equal to the base times the height. Okay. So if in this triangle, my base is RS or UT, probably UT would be a better choice because that's where the perpendicular height is. So area is equal to 32. Well, gosh, I got to figure out what this height is. Well, what I know so far is that if I take this triangle, I know that this is 12 and I know that this is 20. And then I can figure out what my height is from there. And when I look at this, I see that it's a 3, 4, 5 triangle. So my height is 16. It's a multiple of a 3, 4, 5 triangle. So I'm going to take 32 times 16. And so my area, let me shift this over here a little bit. So 32 times 16, I'm going to go ahead and multiply those out. And so I've got 32 times 16 is 500, oops, wrong one, 512 inches squared. So instead of giving you the height and giving you the base, we're giving you other information, and you need to work toward getting the information you need for that parallelogram. Okay, so here we use Pythagorean's theorem, or I knew it was a Pythagorean triple, so that worked. Okay, here's another one. We've got 17, 8. Okay, so it's very similar. The perimeter is going to be equal to double 27 plus double 17. And so 54 plus 34. So the perimeter is equal to 88. I should probably label this. I don't think I did that in this last one. 104 inches squared. Okay. And then the area is equal to the base times the height. And so, whoops, let's just figure out that height. I know it's a Pythagorean triple, and I just can't remember. Oh yeah, it's 15. So I knew this was a Pythagorean triple because 17 and 8, but I couldn't remember if it was 13 or 15. So the height is 15. the base is 27. So the base is 27 times the height of 15. So 27 times 15 is 405 meters squared. Okay. So again, I was using Pythagorean's theorem here. You know, when you think about that, how else could, now here, I was just coming up to it right now, right? Like, how can we figure out, this is a 45, 45, 90 triangle, right? Now we're bringing back those relationships. So a reminder, if I have a 45, 45, 90 triangle, this is 45, this is x, this is x, this is x square roots of 2. And if I have a 30, 60, 90 triangle, oops, let's clean this up just a little bit again, try it again. So this is 30, this is 60, then I have x square roots of 3, and 2x. So I can use that information to help me find the missing side length. So you're going to be pulling those trig functions back. So I know that this is 9. And what I need to do is figure out what those measurements are. So if 9 is equal to h square roots of 2, I can divide both by the square root of 2. So h is equal to 9 square roots of 2. I realize I'm switching my camera here. Square roots of 2 over 2. So now I'm able to figure out the area. So let's circle this up a little bit, shrink it down over here. So perimeter is equal to double 12 plus double 9. Perimeter is equal to 24 plus 18. Perimeter is equal to 42 units. All right. Now the area is equal to the base times the height. Well, my base is 12. So it's equal to 12 times 9 square roots of 2 over 2. So the area is equal to 54 square roots of 2. I think I did that right. 2 goes into 2 ones. 2 goes into here 6. 6 times 9 is 54. Yep. So it'll be units. So here I had to use trig functions, or my special triangle relationships, to figure out what the height was. And I got the height to be 9 square roots of 2 divided by 2. Okay. Now, area of a triangle. Base times height divided by 2, or 1/2 base times height. Use what works for you. I personally like the base times height divided by 2. I know others personally like the 1/2 base times height. Pick what works for you. The whole goal is for you to be successful. All right. Nobody's going to care how your middle school math teacher taught you how to use the area of a triangle. So you pick the one that works for you. And that's good enough for me. Okay. All right. You need to buy enough boards, I don't know where snow came from, to make the frame of the triangle sandbox shown below. If one board is 3 feet long, if one board is 3 feet long, and one bag of sand fills 9 square feet, how many boards and bags do you need? Well, bags of sand is area. So for this, I'm going to take that the area is equal to the base times the height divided by 2. So the area is 64 units squared. Each bag fills 9 feet. So 9 goes into 64, 7 and a little bit. So I'm going to need 8 bags because 7 bags won't quite fill it. It'll be close, but it won't quite fill it. And then how many boards do I need? Okay, so the perimeter is equal to 16 plus 12 plus 7.5. 28 and 7.5 is 35.5, I believe. And if each board is 3 feet, I will need 12 boards. Again, you want to round up, right? Because it's going to actually be like 11 and a half, but you'll need to buy that 12th board. Okay. Ooh, I like this one. Woohoo! The height of a triangle is 12 inches more than its base. Okay, so I'm going to draw a triangle. All right. The height is 12 more than its base. Okay. And the area is 560 square inches. So let's find the base and the height. I'll put my picture over here. I know that the area of the triangle is base times height divided by 2. So the area is equal to B times 12 plus B divided by 2. So the area is equal to 12B divided by 2 plus B squared divided by 2. Okay. So now I have an equation to solve. Quadratic. All right, here we go. Oh, the area is 560. So I'm going to replace that with 560. That'll help me. So I'm going to multiply everything by 2. So 1120 is equal to B squared plus 12B. All right, so B squared plus 12B minus 1120 equals 0. So now I have a choice here. I can do the quadratic formula. I can factor. Let's see what I want to do. X equals opposite B plus or minus the square root of B squared minus 4AC all over 2A. So 144, the square root of 144 plus 4480. So let's see what that is. Oops, I keep turning this. Sorry if you're getting dizzy. Wasn't my intent. All right. So I've got 4624, and I square root that, that's 68. So negative 12 plus or minus 68 divided by 2. So negative 12 plus 68 is 56, and 56 divided by 2 is 28. So the base is 28 units. All right, now the other number is going to give me a negative number, and I can't have that as our answer. So 28 units. Have a fantastic day. We'll catch you in 11.2.